Hello, everyone. Good to be here. Pretty excited, crowded room. A little bit nervous, as of course, in the beginning of the talk. So let's try to reverse engineering like PromQL usage. So how many of you already need to answer the question is like, who is running this pretty expensive PromQL expression and breaking my monitoring system? Raise your hands. Yeah. I think most of us, right? So let's try to understand how we can try to discover that, because I've been in this place a few times now. So who am I? I'm Nicolas Takashi. First of all, I'm Afonso's daddy, this cheeky little boy. I'm a tech lead at Coralogics. I'm doing like platform engineering and a lot of other things, but mostly focused on observability. Also maintainer from Prometheus operator and Persis, and contributing to different CNCF observability-related projects like Thanos, Prometheus, OpenTelemetry, and so on. Cool. So last year at PromCon, I gave a talk about unbreakable Prometheus and how to make your Prometheus more predictable in terms of like memory consumption, the shape of your data, and so on. And someone on the audience just raised a question, say, oh, this is nice, but there's yet another way to break your Prometheus. You can just have like pretty expensive queries going on. And that's true, because if you have too many parallel queries, concurrent queries, touching hundreds of samples, you will need a lot of memory, okay? Luckily, Prometheus provides some limits to that, but this is not the idea of today. I don't want to talk about limits. This resonates with me because I see myself needing to answer the same question that I just asked you, like how to identify those kind of things, right? We don't observe query usage. Like we collect a bunch of data, but we don't know how your users is using the data that we're collecting. We don't know the shape of the data. We don't know what are metrics being used and not to use it. What are the common aggregations that people is doing on our system? How far in the past people is looking the data, okay? So if we don't know all those things, we cannot optimize, we cannot like answer those hard questions in hard moments. So first of all, try to understand like how we can get in this kind of insights today, okay? Because we already have something available. Like first of all, we have Prometheus query log file. For the ones that don't know, Prometheus has a feature that allows you write into a file or to the std out every in-flight query, okay? So you can get in a lot of information about queries that are being made through your Prometheus instance, queries from the recording rules engine, and so on. And you can get a lot of nice insights. But like, you need to configure that because this is not available for default. This is very specific about Prometheus, so if you're running other flavor of backends, you might not have this feature. And later, you need to ship the data from there to some centralized log system or something to do some kind of aggregation. The second one, it's like probably Grafana panel inspector. You can just inspect Grafana panels and see how many rows, queries touching, the time taken, and so on. And the last one is traces, distributed traces. It's pretty awesome, especially if you're running some sort of like Thanos, Mimir, you have many components, you might have like many query instance ongoing, and you can see and spotlight what is the latency and so on. But you have the sampling problem. Sampling is hard in traces, okay? You might need to understand if you collect too much, you might have a lot of problems with amount of data. If you collect too little, you might lose important signals. And traces, they are not so good on answering questions like what is the most common partner that people is executing, or how far in the past people is looking on the data, okay? So luckily enough, community, we have a lot of nice friends in community. We saw today with the Parquet Common, like when you have community joining efforts. Me and Michael Hoffman from Parquet Working Group as well, we were chatting and we noticed that we have like some sort of the same issues as many of you. So we share the same concerns, the same pens, and we discussed that maybe we should build something, okay? Buy would be better, but yeah, we need to write something. But we have few constraints, like we want something that could work cross backend, Thanos, Mimir, Grafana, Grafana Mimir, Cortex, I don't know, Victoria Matrix, and so on. So any The premise is like any Prometheus compatible API. The second one is like we don't want to do any kind of change on the upstream project. It needs to be like very simple. We need to be able to enrich context from the caller in getting more information and exit almost or near real time. So we decided to build like Prom Analytics. Naming is hard, okay? So this is basically proxy. It does exactly what the name says it does. It sits between your clients and your monitoring backend, Prometheus, Thanos, whatever. And it captures context and writes the results that we are getting from the context to a Postgres data store or SQLite if you want to experiment or running a small environment. Okay, so zero change to your backend. It's a Prometheus compatible API and very simple proxy. So how it works, okay? Basically, you have your client in this context process. Process is like sending requests to Prom Analytics, and Prom Analytics just forward requests right away to the backend. When we get the response, we structure the required information, and we push in a Go channel and reply to the client right away, because we don't want to block your query, your query response due to any kind of like analytical processing, okay? And this is persisted async by Go routines. You can have all the controls about like the amount of jobs that you can run to write into your data stores, the channel size, and so on. Cool. So what do we store? This is very tiny and very simple schema, okay? We just store the query, which is the raw PromQL. We store the step, the type to understand if this is a range or instant query, the label matchers that you have on your PromQL, the duration, stat codes, and some specific Prometheus engine fields that you can request to Prometheus query engine about the total query samples and the peak samples. These might be later useful to understand like what is the most expensive query, if we can apply any label matcher to reduce the amount of samples we are touching, and so on. Cool, so let me show you before we continue. Let me see if I can. I have a simple demo running. It's available on the project repository. You can just run it on your own computer. So first thing we have, it run. This is the home page from the project. This is the overview. What you have here is like an overall healthiness from your backend system, okay? You have the distribution about like your query types between instant and range queries, the average duration, your success and error rates. And from this very first row, you can already decide if you need to drill down and looking for specific problems that we will later see how we can find them. The second row, you have like your query time range distribution. Like you can understand how your users are looking, how far in the past they are looking for your data. So if you're running Thanos or Cortex, eventually you might need to understand like how long you need to store your data in your bucket storage, okay? Of course, the reasoning behind that is more than just looking how your users is looking on that, okay? But this is start to giving you some like sneak peek on, okay, people is not looking for more than 90 days or more than 1 year. So maybe we don't need like 3 years of data, you know, we can just cut storage. Although object storage, like it's pretty cheap in terms of like storage costs, like it's always nice saving some resources here. So you can just drill down and see the distribution on stats code, okay, client errors, server errors. We have the query latency, the P99, the P95, and the average, and the same for throughput and errors, okay? And this is the overall overview. So getting back to slides, the troubleshoot workflow should be like looking to the system healthiness, and this gives you an overall idea, okay? Then you can drill down to fingerprints, and I will show you right now the next screen. And you can sort and see the detail. So getting back to the demo, let me just make sure this is still running. We have another page, which is the queries page, okay? So whenever we're ingesting a PromQL a query, we are creating a fingerprint for the expression. So we remove all the, we encode the label, the entire expression, and we get a unique identifier for that expression, okay? What you're doing is like we're basically sorting all the label matchers to make sure that even if you run the same expression but changing the order of the labels, you will end up with the same fingerprint. Because it doesn't really matter if you're changing like first container and later instance and another moment the other way around, it's the same expression. So we create a unique identifier for each expression, and we store that, and then we can see a data table like that. Like this is very weird PromQLs because I'm just using PromQL Smith, which is a project that can generate random PromQL based on your available series. But you can see those kind of things like their usage, and we can see the amount of executions, average duration, error rate, and peak samples for each single fingerprint, okay? So you can just like look in your overall system, you see, for example, some errors here, and you see it's high error or high latency, and you can drill down to the matrix, to the queries page, and you can look sorting for like high latency or high error rate or whatever. And we can look what it's doing, okay? So this is the same view that we have on the home page, but now I'm focused on the fingerprint, on the single query execution. So we can see the PromQL expression here, like if it was an instant or query type. Eventually people can run the same expression, but sometimes using instant, other time using range queries, okay? Also, how far in the past people is looking on this query, and some insights. Later, you can just switch to the executions if you need to look in a single execution specifically. In this one, we only have one. But imagine that you have some of them succeeding, other of them like failing. You can just say, okay, what is the partner? What is the issue with the failing one? It's an instant query or a range query? It's a range query. How far in the past is this range query that's failing from the one that's succeeding? You know, you can start answering those kind of questions. Later, we can enrich this with more information like, oh, what is the user agent doing this query, okay? And you can like approach specifically that user agent. So back into slides. So overview, system healthiness. You spot the issue that you want to find. You drill down to your query fingerprints, sort to find your why. So different sortings tell you a different history. You find the details by looking into the fingerprint execution context, okay? And this is nice. This has already answered these kind of questions for us, like what is the expression, how often the expression is running, how heavy is this expression? Is something that is happening once in an hour every 2 minutes, you can like kind of spotlight if it's an automation running, if it's a dashboard, refreshing interval, all those things, okay? But what if we knew where every metric is used? Because we already have all the data from the queries, right? So if you have Grafana and if you have other clients per se or any CLIs doing queries to the same entry point, you know all the data. But you don't know where this data is being used. You don't know if it's in a dashboard, on a recording rule, on an alerting rule. So we just decide to try to capture that information and correlate with the information that we already have. And again, last year was a very nice conference, by the way. Augustin from the Perses team just had an idea on creating a Go program that can identify where metrics is being used. It's a Go program that you can run, and it will inspect your Prometheus compatible backend, Grafana or Perses, and you can also extend to other sources of where you might be using metrics. And it gives you information where each metric is being used. And what we were looking at, it's this metrics usage project that is now under the Perses organization, can post the results of that evaluation into a file system or posting the results to an HTTP API. So perfect for Prom Analytics because we just need to expose an endpoint that respects the contract that metrics usage is expecting. And we can ingest the usage events through our data store. And this looks like this. Matrix usage is looking to Perses and Prometheus, looking for dashboards, alerting rules, and recording rules. Computing all the usage, like he's getting all the metrics from Prometheus and later intersecting the metrics, the existing metrics with the existing resources and see where it's used and not used. And it's pushing the usage events into an HTTP API, in this case, Prom Analytics. So let's see what we can see right now with that. We have another page here with what we call metrics catalog. So metrics catalog is just based, it's an async background on Prom Analytics, getting all the existing metrics from the upstream service that you configure. And then we can since we are ingesting all the usage events, we can later create this kind of visualization, like all the metrics and where each one of those metrics is being used, alerts, dashboards, recording rules, or queries, okay? So we can just, for example, look for one. I don't know, maybe Prom. I think I have one here. Let me see if this one's being used. Prometheus query. You know, live demo is hard. But anyway, I would like to show you something. Yeah, this one. This one, we can just drill down into the metric itself, and we can see how many series it has, how many alerts it's using that query, that metric, I mean. So one alert, one of one, this is only for the demo, one dashboard and one recording rule. We can see how many queries on your entire monitoring system is using that single metric, and the success rate and error rate for the queries being executed with that. Some other informations, okay, and query latest and so on. So some nice insights that you can get from queries using that metric. You can later see what are the producers for that metric, or basically the jobs, okay, in Prometheus. So in this context, it's just Prometheus, but imagine you have, I don't know, HTTP requests total. It will probably be produced by many different systems on your platform, and you can understand like the amount of series between each one of the producers. This is something that you can also get from playing Prometheus, okay? You could just need to write some PromQL, not big deal. And the other one, it's usage. So we know every query, every alert, every recording rule, and every dashboard where this metric is being used. And you also know all the metrics that's not being used on your platform. So you can start doing answering questions like, is not this metric not being used by anyone? Can I drop that? Is this metric, I need to change a label right now, you know? And if I change a label, what are the resources that will be impacted if I remove that label? This is the kind of questions that we can answer that now we have that. So getting back to slides. So what is next for this project? I mean, we have a lot of, like everything that I show you right now is still on top of that very simple scheme from the beginning. So we're not enriching much more beyond, like besides the data we are getting from metrics usage. So it's nice to see that with a very tiny scheme, you can get a lot of useful and like insights that can be used as data to supporting your decision. So later, this project is like, I want to improve like a lot of user experience because I think this is like, the data is very useful yet, but maybe we need to improve how we present that information for the users, okay? And maybe be more, I don't know, ambitious because we have context about like how users are using your Prometheus metrics. You know how it's being used on dashboards, on records, on alerting, on recording rules, how they are doing ad hoc queries. So we basically know how people are using the data. So maybe we can start providing some recommendations. Like if you're always using a metric with a like specific aggregation, why you need to store all those labels and not drop all the other labels that you don't really need then, you know? Or maybe you have 3 different queries, but they can be, we can like give some sort of recommendation that instead you have 2 different queries, you have a single one that will fit all your user cases, and you can use it in a recording rule or do other kind of aggregations, you know? And also, I've been discussing during these days on the conference, like also this proxy could eventually evolve on a proxy not only for query, but for remoting writing as well. Because if we have information about unused metrics, we can just decide in runtime if you want to drop the unused data or not. And you can just stop sending garbage for your backend, you know, if you're not using. Of course, this is like something that we need to explore, because how you make sure that like you need this data later, how you can use, you know, but it's something doable, and with user permission, they can just do that. So that's it from my side.
Awesome. Questions?
Hello. Hi. You said that this product can help us to protect ourselves from, example, too long queries that, I don't know, query for high cardinality or something. Is there some metric that we can use to alert ourselves if there are, I don't know, too many queries from a dashboard or something like this? Or is it just exploratory?
It's a good question. Like at the moment, I don't think there is any specific query that gives you, oh, this fingerprint is being executed too often, because, like, first, because every fingerprint later will count as another high cardinality data on your metrics backend. So this is one of the reasons not exposing. It could be exposed eventually. We don't have any limits in place, so it's basically collecting sites. Usually, if you're running other backends like Prometheus and Thanos, you have limits configuration for queries execution, so you can configure how many samples one single query will touch, how many parallel queries you will run. So the project is just leveraging the limits for, like, hand over the limits right now for the backend and just focus on giving the insights, you know.
Hi. Yeah.
Hello.
Thanks. Great talk. I have 2 questions regarding source of the queries. You are using the metrics source, like the component from process you showed. But I'm wondering, did you consider using, for example, a user agent or some HTTP headers for grouping of the source? Because, you know, there are sources of queries which you won't be able to integrate to the metrics finder, or sorry, I don't remember the name.
Yeah, that's a good one. Actually, there is an issue on the repo to allow us store specific user agents that we can later show them on the UI. So this is something that's mapped, not developed yet, but would love to get this. I think the mic don't like questions, you know.
Working. Just quick question about multi-tenancy support. I know Thanos and Mimir do have multi-tenancy. Do you plan adding something about it to the proxy, or?
I mean, maybe if I mean, it might be very simplist, but if you allow header extractions, we can just extract a tenant header from Thanos and from, like. It's more complex because this is like you need to put this like after your Thanos query front end, for example, and before your Thanos query. So we can get in the tenant ID from Thanos, but like, yeah, worth a discussion.
Yeah.
Where?
I have a question. My short question is, how basically does it scale? I mean, to elaborate, we in Amadeus really are interested to use your tool because it's really giving things that we want to observe and we don't manage to, or partially thanks to the metrics usage. And I'm wondering if I should just put your proxy in front of our big Thanos that handle a lot of Thanos behind the scene and a lot of Prometheus. I think we have hundreds of Thanos and thousands of Prometheus behind. So if we do this, will it really scale, or do we have a way to put the proxy in front of each Thanos query and like make them aggregate in one UI?
Yeah, that's a good question. I mean, scale is very subjective, you know, like everyone has its own definition of scale. What I can tell you with few characteristics. This is a stateless service, so you can just spin up as many replicas as you need. You can, for example, choose like one instance per Thanos and pointing all of them to the same data store and later access the UI for a single instance. You know, it will work. Since we are like persisting all the analytic data in background, you can like scaling vertically, but increase the amount of Go routines, computing resources, and so on. You can also run multiple replicas. I'm running that in production like nowadays, and we are handling like 40K, 50K PromQL queries per second. It's like pretty tiny, I think less than 1 GB per memory per instance. So I would say that, yeah, should handle pretty fine.
Okay, so you would advise me to put a proxy in front of each instance instead of the big one, actually?
Like my case, I'm running, it's like I have one source of data and then I have proxy as a sidecar on each one. But
yeah, okay. I will try. Actually, this is very interesting. Thank you.
Thank you.
One last question.
Hi, nice talk. Thanks.
Thank you.
I think I'm pretty sure I missed something on the architecture, but I was curious why what's the reasoning behind the decision of building a UI on this project? I mean, the proxy, as far as I understand, stores data on some data store. So why is this not a data source for Perseus or Grafana? And then instead of giving a UI, you provide dashboards that people can install on their, and feed back into the landscape that we already use.
Good question. 2 reasons. One is like even or Grafana or Perseus, to get this kind of drill down between these different UIs, you probably need to build a plugin, because you can have one dashboard with the overall system and then another dashboard where you can have some variables and so on. But like, I don't know, I don't think it's too fluid, and you need to maintain 2 different plugins. Although this is something that me and Augustin, we already discussed, like maybe might be useful in the future, provide some plugin for Perseus and they can just see everything on the same place. The second one, it's like just easier to experiment with the data, It's just a React application, so aimed on Go binary. It's easier to explore, easily to change, mainly that. Cool. Thank you.